So before we actually dive into the session, how many of I want to get some metrics from all of you people. So how many of you are good with Python? Because Python is a prerequisite. Okay, okay. So that's a good number of hands raised up. Cool. So how many of you have already started your journey with machine learning? Okay, okay, cool, great, great. Okay, fine. So this is the first session in this study jam series out of eight, and the first session deals with the introduction to machine learning concepts. So what actually is machine learning? Can anyone guess the answer? What is machine learning? I hope this session will be interactive because I'm not some kind of a professor at a university to just dash into the classroom and write something on the board, put up a presentation and talk. You are free to answer and nobody's gonna judge you. What is machine learning? Can somebody guess or share their opinions or views? Mm-hmm, mm-hmm. Yes, exactly. That's a great answer, Bhuvan. So, machine learning, as Bhuvan stated, is uh, you providing the ability to a machine, to learn and predict stuff. So, if you teach machine mathematics and you give it complex questions, or you provide the machine some images of animals or different kinds of objects in this real world and tell them what those objects are. It will recognize the patterns in it. It will learn according to the provided data, and then it will predict the further questions for you. That is what machine learning is in a nutshell. So before we go deeper into machine learning, there are two terminologies: artificial intelligence and machine learning. Both of these terminologies are almost same, but there is a very small difference between AI and ML. Artificial intelligence deals with many aspects where machine learning is a part of it. AI means you can, you know, the computer vision and guessing stuff and, you know, uh, all these OpenCV, all these packages come under artificial intelligence, where machine learning only deals with taking data and finding patterns and predicting the stuff. AI is a large world where machine learning is just a part of it. So that's what is the difference between AI and ML. So to build a machine learning model or to predict some stuff, you need to have data and you need to build a model, train it, and then execute it. So how does models work? For the models to work, firstly you need some data, and then when you get the data, you need to feed it. You need to clean the data and then feed it to a machine learning model. And then once you feed it to a machine learning model, it will extract all the features from that data and then find a pattern between the data. And then when you provide it new data, it will predict that. It will predict the answer. So that is how a machine learning model will work. Moving further, there are three types of learning, of which first one is supervised learning, the second is unsupervised learning, and the third is reinforcement learning. The supervised learning is if you have data, in that data, you know what the input is and you know what the output is. That is called supervised learning. Unsupervised learning is you have data, but you don't have what the data is. Reinforcement learning is based on rewards and punishments. I'll brief you about this. So let us take a situation where uh, you have mixed images of cats and dogs. Let's say you have a folder, and in that folder you have 100 images, of which 50 are cats and 50 are dogs. And you are building a machine learning model to to predict which image is the image of the cat and which image is image of a dog. So when you feed this data into a machine learning model, you're going to tell the model there are two metrics. The first one is the image, which is either the image of a cat or image of a dog. And you're going to tell the model that this is the image of a cat or this is the image of a dog. So then the model, what it does is it will extract the features from that image. Like a cat has small eyes and it has a small tail. It will have no fur. It is, idle kind of stuff. And then it will take all these features and label it as cat. And when it comes to pictures of dogs, it will extract all those features of a dog, like long ears and furry dogs, and they're stout, they're big, and it will extract all this stuff, and then it will label them as dog. So that is supervised learning. You will have labels for each and every data you have, and you predominantly tell the model that you give the question, you give the answer to the model, and the model will figure out the equation between the data, relation between the data. That is supervised learning. Unsupervised learning deals with no labels. You only have data. Like if you give the same hypothetical situation where you have 100 images of cats and dogs mixed up in a folder, and you feed it to a machine learning model, and then the unsupervised learning model can only classify them into two categories, which is of which there is a category 1 and category 2, whereas category 1 is cats and category 2 is dogs. It cannot, specifically tell which is a cat and which is a dog. It can only classify things. It will not have any labels. That is unsupervised learning. And reinforcement learning usually deals with game bots, right? Have you ever heard of game bots like chess bots and many other games have bots, right? Anyone, have you ever played online chess before? Okay, so such kind of bots where there is a computer playing as your opponent. That those are also machine learning models where it deals with reinforcement learning. When a chess piece, a bot makes a correct move in a chess, then it will get a reward and it will know that, yeah, this is the correct move. And if it makes some sort of a wrong move, then it will know that, then it will get a punishment, which is the negative reward, and it will know that this is the wrong move. So that is how reinforcement learning works. These are the three main types of learning in machine learning. And apart from different types of learning, there are four metrics, which are losses, validators, optimizers, and activators. Uh, excuse me, losses, validators, optimizers, and activators. Where when you train a model, you need, let's say, you have 100 rows of data, and then you're training the model with the data. And at each and every, iteration, it will compare predicted value with the original value. And let us say if you take a data of 1 plus 1 is equals to 2, and you're training a machine learning model to add up two numbers, and you provide the input data as 1 and 1, and you provide the output data is 2. And when you're training the model, if it accurately guesses the value as 2, which means if the model can accurately guess the answer, then the loss is very low. If it is very close to the answer, then gradually the loss increases. So the difference between the actual value and predicted value is called as the loss. And basing upon the loss, it will validate the model. It will optimize the model to reduce the loss. And the activator deals with finding patterns between the data. We will come to know about these four metrics in our future sessions. This is just a gist of what loss validators, optimizers, and activators are. So, in this session, we'll be talking about supervised learning algorithms, of which classification and regression are very popular. There is a difference between classification and regression. Classification is it can only classify data into two categories, which is, let us say, gender. If you give two images, if you give an image to a model, it can only classify it into either male or either female. It is called as classification. It can only deal with binary values, which is, it can only like it can only divide the data into two categories, which is classification. And regression is not like that. Regression can take up multiple values and predict the whole outcome, which is, let us say, you're buying a house and you need metrics to buy a house. What metrics you might see, which is number of bedrooms, you have a hall, the square feet, the location of the house, the sceneries or availability to supermarkets nearby, availability to shopping malls, and how populated the area is, availability of pass. These are many metrics. These are not only just a single or two metrics where you can classify as male and female. These are many metrics. So regression can help you with taking multiple metrics into account and predicting the price of your house. So examples of classifications and regression are decision trees, random forest, k nearest, and SVM. So in these machine learning study jam sessions, we'll be going through the Kaggle Kaggle courses which are provided by Google itself, and I'll be sharing the screen in a second. Yeah. This is the first course related to the first session, Intro to Machine Learning. I'll be walking you through this course in which there are 7 lessons, and you can finish this course in your free time to receive the certificate for this course. And this will be the prerequisite for our next session in the next week. Uh, Dealing with the first chapter, how does models work? And this is a sample decision tree. As I've stated the hypothetical situation before, if you're buying a house and does the house have more than 2 bedrooms, and then the price will be 188,000. And if it doesn't have more than 2 bedrooms, then it will be 178,000. So this is how decision trees work. If metric is positive, it will predict into one value. If it's negative, it will predict into other value, and it will have more than one metric, such as if its lot size is larger than 8,500 square feet, then it will have one value. If it's not, it will have another value. In such metrics, it will predict the values. So in the next session, we'll be getting familiar with pandas. Uh, and okay, so taking the same hypothetical situation, we have a data set called Melbourne housing prices dataset, and you'll find the dataset in Kaggle itself. Running this code snippet will give you this output of different prices and metrics of rooms, distance, postcode, number of bedrooms, and car parking, land size, etc. And after you get familiar with the data, you just have to, okay. Okay, once you have a data set, the first thing you're going to do is to clean the data set, because you always not have complete metrics in your data set. In some cases, the columns or the cells of the data will be missing, and in some cases, the prices will be missing. There are many loopholes in the data set, which will reduce the performance of your machine learning model. So the first thing you're about to do is clean your data set, and then you have to choose your prediction target. In this case, we are predicting the price of a house based upon the location of the house, the number of bedrooms, and its metrics. So we are about to predict the price. So we'll be choosing y is equals to the price of the house. And the features we are taking into account are number of rooms, the number of bathrooms, the land size, the latitude, and the longitude of the house. So X will be the all these metrics from the data set. This is the usual convention you use while you're building a machine learning model. After that, you can just verify your data by describing the data set, and then you can check with the first 5 rows of the data set by using the head method from pandas. We'll be covering all these methods in our next session, which is introduction to pandas. And then the 4 steps to building your model is defining the model, which is there are different types of model like classification of images, or linear regression or decision trees. So you have to choose uh, the correct method for building your model, and then you have to fit the model based upon the data, and then you have to predict the data and then evaluate how accurate your model is. So for predicting the prices of our housing data set, we'll be using a decision tree regressor, which is, as we discussed before, it will take multiple features into account, and it will predict the a single output, which is the price. So we'll be taking the decision tree regressor from scikit-learn, which is the default package we're going to use across this course. And then from scikit-learn, we'll be importing the decision tree regressor, and then you will be providing it a random state, which is the shuffling of data, which is we'll be dealing with it in the future sessions. And then we'll be fitting the data to our input features, and then we'll also be giving the output, which is the price. And then once the model is fit, you can predict the data by providing it another set of data, and then you'll get the prices. So once you're good with building the model, you have to validate your model, because uh, your model does not usually doesn't perform well, because it will always get very close to the answer, but it cannot exactly predict the answer. That is how models work. Getting 100% accurate model is very rare in machine learning. So once you are done with building the model, you will be providing it a new data, and then you are going to validate the model. So the usual formula for validating the model is error is equals to actual minus predicted, and you are aiming for getting low errors. So once you are done with predicting the prices, and then you will be calculating the mean absolute error, and then there are many types of error metrics, which is mean squared error, and that different things. And then you'll be calculating the mean absolute error with the predicted prices and then the actual prices. And you must always be aiming for the low error. If there is a high error, and you have to tweak your model parameters to get low errors. So once you're done with the model validation, you'll have your model ready. You can export it, and you can use it in different cases in your webs or applications. And there is another problem while building your machine learning models, which is underfitting and overfitting, which is if you have a data, let us say you have this linear regression tree, and then you have you are dividing your data set into very diverse categories, such that in terms of lot size, and in terms of number of bedrooms, in terms of local availability, in terms of the population. If you divide it into diverse categories, and in each category you will only have one or two rows of data, and then your model can only concentrate on that part of data, and when you give it new data, it cannot accurately predict the data. It cannot accurately predict your price, which is called underfitting. Uh, or else, if you divide the data into very low categories, in such a case, in each category you have many houses. Even in that case, it cannot exactly predict the data, which is called overfitting. Yeah, you should always deal with underfitting and overfitting, so that you get your uh, correct metrics in exactly one point of your data. So you must always deal with such kind of problems while dealing with building machine learning models. And you can, this is a kind of, dealing with this underfitting and overfitting problems, where you also provide maximum leaf nodes, which is you are not dividing the tree into multiple levels. You can only have a set of predetermined and prefixed rows in every tree. So the max leaf nodes parameter will decide that metric. So once you are done with building the model, you are going to calculate mean absolute error for that model, and then you'll conclude your model. So that is a very basic introduction to what machine learning is, and you will be getting a gist of it once you finish this course, and you'll have the certificate once your course is done. So for any doubts, you can contact me on different Instagram handle and social media handles. And if you have any doubts, you can just pop it out here. No, you'll be completing it. It is kind of a homework. You can complete it before you attend the next session. The course is a very basic course. It is a beginner level course, and you'll have a little bit of code relating to scikit-learn package and pandas. The in the next session, we'll be dealing with pandas and the very important methods and classes in pandas, so that you'll get a whole complete idea of it. Meanwhile, if you have any doubts or questions, you can reach out to me.